All right, class, the first day in 2 we looked at random sequences. Today we're going to look at a specific one, and we actually looked at this one already, you just didn't know it had a special name. It's called an arithmetic sequence, and it's a sequence when you have all the terms in a row have the same difference in between them. The recursive function is defined as this. You're given a value, and then the next value is equal to the previous value plus d, where d is the difference between the current term and the last term. And we call this the common difference. Okay? Now they follow the pattern like this. So let's think about this. If I have my first number a, okay, let's just say it's like 5. The next one's going to be that term plus the difference, because the difference will be the same. The next term will be that one plus a difference and a difference, so another difference. So that would be 2 differences. To get the fourth term, we start with the first term and add 3 differences to it. So because this is always the pattern, you can define the nth term of an arithmetic sequence as a sub n, so whatever term you want to know, is equal to the first term, which is also a sub 1, but I'm using just a here, plus the difference times, and if you notice, there's 1 difference for the second term, there's 2 differences for the third term, there's 3 differences for the fourth term, so this is an n minus 1. So that's one of the formulas you're going to have to remember, and we're going to pretty much use it all day today. So we'll show you how it works. So find the nth term of the arithmetic sequence. That means I want a sub n, the equation, and then it says what is the 9th term. So first thing I'm going to do is set up my nth term. A sub n is equal to, it tells me a is 5, plus it tells me my d is 3, n minus 1. I FOIL it, or I distribute that, and then I get a sub n is equal to 3n plus 2. So that would tell me whatever term I want for this sequence, if I know that it starts at 5 and it goes up by 3s. Now it says I want to know the 9th term, so a sub 9 is equal to 3 times 9 plus 2. So we get 27 plus 2, a sub 9 is 29. And that's all we're doing today. Now we're going to look at different ways of looking at these. I might give you different starting points, but the same formula applies every time. So the next one, we have the starting, well, a sub n is equal to the starting point plus the common difference times n minus 1. Because I don't know what n is, and I want a sub n in terms of n. 6n minus 6. So we get a sub n is equal to 6n minus 10. And that's that. And then we need to get the a sub 9, which is 6 times 9 minus 10. So that's 54, which is 44. Okay. This is a little different. We have to do more work. We need to find the nth term again. That's always the best thing to do, is find that formula, and then you can find whatever you want. So we need to find the 20th term, but we'll do that later. First we need to figure out the nth term. And again, in order to do that, we need a and d. So we know a is negative 3. And d, you have to figure out what's the difference here. What's 5 minus 1? What's 1 minus negative 3? What's 9 minus 5? The difference is a positive 4. So d is equal to 4. So now we do the exact same thing we did above. Come up with our nth term, because that's what they asked us to do. Now I'm going to kind of skip steps here. This is 4n minus 4 minus 3, so it's 4n minus 7. And then it says, on this one I want the 20th term. So it's 4 times 20 minus 7, which is equal to 73. Okay? Alright, so same pattern. If you're getting this, try to pause it maybe and see what you can do. Again, we need the first term, a is equal to negative 5. And then we need to figure out what's going on here. Negative 9 minus a negative 7 is minus 2. We're subtracting 2 each time. So d is equal to negative 2. So that means I have a formula, a sub n is equal to the starting point of negative 5 plus a negative 2 times n minus 1. A sub n is equal to negative 2n. That becomes a plus 2, and then a negative 5, so that's a minus 3. So there's my a sub n term, and I want the 12th term for this one. All right, so we get negative 24 minus 3 is negative 27 is the 12th term. Okay, let's go on. All right, this gets a little more challenging. This time I'm actually giving you a term number, like the 19th term is blank. And I tell you what D is, it's negative 3 for like number 5. So the problem is you need to come up with the nth term again. Well, in order to have the nth term, you need the first term and the common difference. We don't have the first term yet. But we can use our formula to get the first term. Because we know that a sub 19, that means that n was equal to 19. So in the formula, remember this is the formula, we know that when this is negative 45, that's going to be 19. So we can set up a formula and say, well, when we knew that the 19th term, negative 45, is equal to the first term, we still don't know the first term, plus negative 3, because that's the difference, times 19 minus 1. So now we can simplify that. We get, when you simplify that, you get a is equal to 9. Now we can find the nth term like before. A sub n is equal to the first term plus the common difference times n minus 1. And the reason we're doing this is just so we get a nice formula so we can find anything we want later. Negative 3n plus 3 plus 9 is plus 12. And then finally it said, can you give me the first 3 terms? Well, this you don't even really need the formula for. We found out that a sub 1 is 9. A sub 2, what are you just doing to this? You're subtracting 3, so this one should be 6, and a sub 3 should be 3. And you can test your values based on that by plugging in. Okay? Again, we're going to use that formula in reverse, so we know that when it's the value of 52, we don't know what the first term was, but it went up by 6's, and we were on the 12th term to get to that. So we get a is equal to negative 14. Now we can write our nth term just like the front. A sub n is equal to the first term, negative 14, plus the common difference times n minus 1. A sub n equals negative 14 plus 6n minus 6. I don't know why I just didn't do 6n minus 20. Okay, so that's the a sub n term. And now you can plug in 1, 2, and 3 to get your values. Or again, you can just say, well, a sub 1 is negative 14, and then a sub 2 has to be 6 more. So that would be negative 8. And a sub 3 has to be 6 more, which has to be negative 2. Okay? The last thing we're going to do today is use a system to find both pieces. Because in this one, I'm not giving you the difference or the first term. But I am giving you 2 other terms. So for this one, when n is 6, a sub n is 10. When n is 21, a sub n is 55. So we can put these formulas up and say, okay, when a sub n is 55, I can use my formula. We don't know what a is, we don't know what d is, but we knew that n was 21 minus 1. Well, n is 21. So there's my first equation. The reason why we need 2 equations, if you guys can see this, we have 2 variables. Can't find a variable unless we have 2 equations. So this other one is saying the value is 10 when n was 6. So if I rewrite this over here and set it up as a system, here's what's always going to be nice about this. You can always just subtract these, and the a's will go away. So if you subtract, you get 55 minus 10 is 45, equals nothing. 20 minus 5 is 15d. So we get d is equal to 3. Plug that back in over here. You get, I'll use the smaller one actually. 10 is equal to a plus 5 times 3. So that's 15 minus 10 is 5. Or negative 5, I should say. It's 10 minus 15. A equals negative 5. Alright, now we got the pieces that we needed from the beginning. We can go back and make our nth term. So I'm going to write this because it asks for the formula for the nth term and a recursive formula. So we didn't ask for that yet. We'll do that at the end. First, we'll do what we normally know how to do. A sub n is equal to the starting point plus the difference, which we know is 3, times n minus 1. So we distribute that, we get 3n minus 3 minus 5, we get a sub n is equal to 3n minus 8. So this is the nth term formula right here. Now let's talk about recursive. We know what a recursive formula is, we just haven't done it with these. But these are actually one of the easiest recursives to do. Remember, for a recursive formula, you first have to state where we are starting. We are starting with a sub 1 is equal to negative 5. And then for any arithmetic sequence, what are we doing to get to the next term? We're just adding the common difference d. So the next term is equal to the previous term, and then the difference is 3, so plus 3. And that is the recursive formula. Again, you need the starting point. The recursive formula lets you start at 1 and work your way through the sequence, and again, the nth term will allow you to find any term you want. Okay, let's do one more. Again, it's telling us that n is 5 when a sub n is 10. N is 30 when a sub n is 110. So we have 110 is equal to a plus d times n was 30 when it was 110. And then the value is 10. Again, we do not know a or d, but we know n was 5. So I'm going to simplify over here. I get 110 equals a plus 29d, and I get 10 is equal to a plus 4d. Subtract, you get 100 equals, these go away. 29 minus 4 is 25. And then we get that d is equal to 4. So that's one of the two things we need. Plug it back into I use the smaller equation. 10 is equal to a plus 4 times 4, which is 16. 10 minus 16, a equals negative 6. Alright, I have the pieces I need now to find my nth term. Actually, I'm going to, since I'm asking for both, and again, that's the key, just look and see what I want. The nth term is a sub n is equal to the starting point plus 4 times n minus 1. And then if you simplify that, you get 4n minus 4 minus 6 is minus 10. And then we're done with that one. And we have one more thing we have to do, the recursive. The recursive, you need a starting point. A sub 1 is equal to negative 6. And then we have to say, well, with recursion, we need to say, what are we doing to this term to get to the next term? All we're doing is we're taking the previous term, which is a sub n minus 1, and we're adding 4. So those recursive formulas for arithmetic are very nice. So, alright, so that is arithmetic. Again, it's always the same formula with arithmetic, but in order to use this formula, you have to know that it has a common difference. It's adding by the same number each time.